Okay, I see that it's officially 11 o'clock, so I think we can kick off. Good morning, everyone. Happy Friday. I hope you're doing well wherever you're logging in from in the world. And thank you for joining me for part two of the series. I just want to say it's really a pleasure hosting the series, especially from the feedback received from various designers, technical personnel that found it very insightful. So thanks very much. And we are more than happy to actually help you design and make a better world. And today we're going to be heading off on part two of our Intelligent Stormwater Design series, hosted by myself. I am Shuaib Yunus. I am the BIM Technical Specialist for Civil Infrastructure and Mining here at Baker Bay in South Africa. And we are going to be diving into this design task at hand for a stormwater network. So from the user list that I'm seeing here today, I am pleased to say that most of the users that attended part one are here, so great. It'll make a lot more sense to you. For those that are attending for the first time, which there is quite a bit, this three-part webinar series, just to give you an overview of it, it was to design a stormwater network intelligently. Okay, being a civil design engineer, I also know that in consulting we don't have the best way currently for stormwater design or most pipe networks in general. So I thought I'll put through a three-part series targeting these three core topics. So as you can see for part one, which we had finished or ticked off, we focused on the actual modeling layout of the stormwater network. So how you would normally do it in AutoCAD. I hope you're not using AutoCAD still, but the principle is more or less the same, just more intelligently and streamlined as you've seen in the last webinar. Today, we're going to be on part two, which is focusing on analysis. Again, it's going to be a very heavy technical webinar, much more than the previous one. And then, of course, part three is going to wrap up the production and quantification. So if that sounds good, let's hop into today's session, more or less what we're going to be covering. Of course, we always give you a quick intro on who we are because we have new people joining in all the time. And then, of course, I have a lot of users that emailed me during the course of the time to this webinar, inquiring about this, where they've heard it, but they're not quite sure of the overview, how to explain it. So I've put in like, I think 2 or 3 slides just to tell you what it is and what it does. Thereafter, we're going to jump into the stormwater design part of it, the technical design part of it. And of course, we're going to do a recap of part one, just quickly what was covered. So if you're a bit hazy or you didn't attend the first webinar part one, don't worry, I got you covered there. But as you can see under the part two, we've got quite a bit to go through. So I'm gonna do a quick blitz through it. Again, it's not gonna be click by click instructions, but I want you to understand what you're doing before you can even touch a computer or mouse or whatever. That is my goal as a designer to give it to you, right? So as you can see, we're going to be looking at ensuring that the network is actually labeled logically. That's where we actually stopped last time. So I'm going to show you how to do a branch, how to label it in a sequential manner. Thereafter, we're going to jump into generating the vertical profiles or the long sections. This is where people always get a lot of queries in Civil 3D, but I'm going to show you how to tackle them very quickly. Thereafter, we're going to go jump into defining the catchment extents. This has been a tedious task always without using intelligent technology because it wasn't that insightful, but you will see when we're going to be covering it how much better it is now. Thereafter, we're going to input the catchment properties for rational method. Of course, it's used from the Sandroll Drainage Manual, one of the options, option 1 there. So if you are familiar with that blue book, you should be very clued up following the process. Thereafter, we're going to run the stormwater analysis to check if everything's good, if you're getting any errors or we need to maybe readjust anything. And then we're going to wrap it up to ensure that the data that's present on the band set is correct so that when you're going to part 3 of the webinar soon, all of the drawings that you're going to create are of correct values. And then, of course, I'm going to wrap it up and let you get on with your awesome Friday. Okay, so a bit about us Baker Paints. Of course, we live by the motto helping you to design and make a better world. If you're looking at the segments part, again, 4 critical segments. We specialize in survey, design, hardware consultancy. We do design software consultancy, blended learning, which is a key element to have, especially in these times, unfortunately. But not only as that, if you're a designer working on a deadline and you're working those late hours of the morning, um, you want something online to give you a backup when there's no real human support sometimes at 3 o'clock in the morning. Okay, so it's a really good thing to have. And then, of course, we look at business process improvement and consulting. So what I want you to take away from here is more or less on the left-hand side, we are a Autodesk service provider select. And what that means is we have the technical capabilities, the technical personnel to actually deliver consulting at a very high level quality, else we would have not gotten that. So we have the capabilities to actually help you with that. And then, of course, we are partnering with various brands, which I'm going to jump into in my next slide. So again, I'm sure the users that have been attending the webinars, have seen this a lot of times. So I hope you probably memorized my intro by now, but we do specialize in Autodesk software, being that we do sell it, but we do more than that, but rather we offer the consulting behind it, we offer the training, whether it's online, blended learning, e-learning, face-to-face, or on your premises. So we do offer that. So we help you adopt the software rather than just giving it to you and letting you figure out for yourself, which is a nightmare if you are new to design. Okay, so we are Autodesk certified. We do have training centers here in South Africa, and then of course we do a lot of training online for clients abroad in Africa, Europe, and so on, like that. Okay, and then of course we also specialize in actual 3D laser scanning. Okay, so 3D laser scanning, we've got 2 main technologies that you're looking at, or hardware. That'll be Leica and Topcon. So if you have seen any of the Leica or Topcon laser scanning, or you've been following my Scan to Boom webinar campaigns, you would know that the Leica, the one, let me just click here we go. So that's the BLK 360, and it's widely adopted in the Scan to Boom workflow. I actually used it yesterday on a mine that I went to. I scanned a really nifty piece of tech. So it does work really great, and the results were fantastic. Also, I've used it on my last webinar. You can also check that out, but I'll give you the details at the end for that. So that scanner is actually used for interiors predominantly in the built environment for architects and stuff like that, but it can be applied in a wide range of applications if you know what you're doing. But if you're looking for something more rugged, so if you were on the construction, civil engineering, mining segment part of things, I would say look at the Topcon. What you're seeing on that picture is a GLS 2000. It is a really rugged scanner, very big. It looks like a total station. It's got the reminiscence of that if you have used one before. And it has a really wide or long ranging scanner starting from the entry level being 300 meters. I think it's about 120 meters, and the high range going up to 500 meters, which is a lot. Of course, CAD learning. Like I said, if you're a designer, I say this is a must. You should have this. It has predominantly most of the Autodesk software that's online that you can learn. So if you want to learn, for example, Civil 3D, you'll click on Civil 3D. It has all the topics in there: how to do a road, how to do platforms, how to check the settings. There's videos to help you walk through it, as well as it allows you to test yourself at the end. So you can do a skills test to see what you've got wrong, and it'll give you a custom playlist to actually help you become a better designer or focus on those key areas. And then, of course, in the same videos, there are exercise files that you can download and do with the person in the video. So very brilliant thing to have. Please have a look at it. Please, maybe if you want a trial, take it for a test drive. But most of the designers and colleagues in my network actually have it. And last but not least, it's iDAS, which is the focus of today's webinar. You can have an intro of it just now. Okay, so these are the main segments that we cater for. So build being anything vertical, so your architectural buildings, your structural buildings, anything built environment related, we do specialize in that. Manufacturing, which is a key segment now that's linked to civil engineering and mining because of modular construction and stuff like that. We cater for that. And then of course, energy. You can see these are the 5 key segments of any country or any specialization field, and we always work or interrelate with each one of them, and we support each one of them. So the advantage with that is we understand the entire ecosystem, and we help you to collaborate in a manner that's going to work on your projects. Okay. And then we base this on our iAdopt methodology, which is custom to us. In a nutshell, we apply our own secret sauce to allow positive change management. That's all I want to say about that one. Okay, right. Now that you know a little bit about us, for those that are new on here, let's jump into why we're using iDAS with Civil 3D. Because a lot of people know what's iDAS, what Civil 3D is, but not really iDAS. So iDAS actually stands for Infrastructure Design Automation Suite, hence it's easier to call it iDAS. It's developed by a Devotech group of companies, and it's an add-on to Civil 3D. Of course, they have office here in South Africa and New Zealand, and the great thing is it's in constant development, being very close to the clients to see what challenges they are currently facing in the civil design industry. We, of course, Baker Benz are a reseller here in South Africa, but why I would strongly recommend you use these two in conjunction. First of all, it gives you full BIM capabilities of Civil 3D. So if you've been using standard Civil 3D on its own, you should realize, if you've been using it every day, there are certain things that are not quite up to scratch or need improvement or development on. And this is where iDAS comes in to actually fill in those gaps, all right? So today we're actually looking at the pipe networks parts of stormwater, but you can also use it for a variety of things, as you can see on your screen. So it can be used for roads, for platforms, stormwater, sewer, bulk, water reticulations. It is really nifty and it's really intelligent. The application of it is absolutely great. And you will see this because it has localization standards for South Africa, as well as it contains the pipe catalogs that are already pre-built into Civil 3D. So you got the best of both worlds. And for me, the game changer is doing everything in Civil 3D, not needing to export it to another external application, bringing it back in, checking it, and so forth. Everything done in one application. If you're interested again in a trial or taking it for a test drive, you can head over to the Devotech website. I just put a snapshot there. If you can download it. There's a lot of learning videos that I've done, brilliant videos done by Antonin. You can actually have a look at it that are much more slower in pace than what I'm going to be showing you now, and much more in detail. This webinar is just to give you more or less the methodology behind how it works, and today we're going to be looking at stormwater. Okay, so all the formalities and all of the background given, let's jump into the topic at hand. And we're going to start off with a recap of what we've done. Okay, so I see that there is questions already for the first webinar. Where can you get a recording? I will give you the details to our YouTube channel at the end. And also, I would mostly address all of your questions. So if you do send questions through right now, I will address them at the end. If anything pops into your mind, feel free to hit it in the chat box. But just for time and to not disturb the flow of things, I will get through the content first, and then I will tackle your questions at the end. All right, so let's have a recap of what's going on. So this is what I had created, right? So this was the project scenario. First of all, I took a site chain, Johannesburg, South Africa, actually close to Mall of Africa. We geolocated it using InfraWorks and Civil 3D, and we created a final road design that needed a stormwater network. Very realistic consulting or real world example, right? Geolocated, also localized here to our South Africa. And What we needed to do is to first model the network, stormwater network. We needed to analyze it, which is now, and we're going to be doing the production. So again, we finished model it already. What we're going to do now is we're going to be doing the analysis part of it, right? So I just thought I'll put in a small snippet on it to see, so you can see what's going on or what methodology was applied for part one if you missed it. Okay, if you wanted to break it down into topics, so part one, what we did was I gave the users an introduction to iDAS of the interface itself. Then we applied some watersheds to derive the catchments and the low points for our curb inlet positions. We then set out our stormwater network using polylines. So how you would normally draw it with AutoCAD, just that we added intelligence to it by using the iDAS stormwater wizard. And then after that, we swapped some structures, and then we just checked that the flow and the labeling was done correctly. And that's where we're going to be picking off today. So today, what's going to be covered is we're going to ensure that the labeling of the network is correct and logical. Then we're going to create the long sections, check out the profile, see if everything's looking good and technically sound. We're going to then define the extent of the catchment and, of course, its properties to run the rational method, execute the analysis, and then update the data so it displays correctly in the profile view band. Okay, I hope you're all set. Let's jump into it now. So you've got the picture. Let's start driving into this design. So first one will be checking if everything is labeled correctly. So you can leave it in a non-sequential order. It will still be correct as long as it's on your drawing. But a lot of clients or consultants prefer to be in a systematic labeling convention. So let's have a look in Civil 3D what we got here. Okay. So this is the actual road. If I zoom in, you will see that the super elevation is displayed as well. Pretty cool, right? And that is the curb inlet that I have attached there. You can see we've used the naming convention. The water is actually going to be flowing down this way. So for you that missed the first one, it's going to be flowing down. You can see there's another curb inlet, and we've got our outfall at the bottom. And we've got the other branch that's starting from the top there, coming down. We've got this one here at the bottom, which is going to drain up into that and tap into network 2. So everything is draining down towards there. Again, you can see I've left the surface style on, so you can actually see how the road is actually designed to facilitate the stormwater design, which is very important. The road needs to be a contributing factor to the successful or proper design of a stormwater network. So I've left one branch that I intentionally renumbered incorrectly. So you can see we've got weird numbers there that don't make sense. But that's the branch that's coming down, and it's going to be tapping in to network 2. So if you do not understand my naming convention, you are going to be able to see it just now. Okay, so I'm going to go and label one of the pipe networks here. So I'm going to select that curb inlet because I know that's the starting of that branch. And it comes down here, and it's going to tap in before manhole 2.1. So I'm not going to click on the manhole, but rather the pipe, because remember, that is tapping into the main network. So network 2 is the main network. So I'm happy with that. You can see it highlighted the entire network, meaning that the pipes are connected. If it did not, that means something's not connected. You need to go and check your pipe network. All right, so we're going to be using a naming convention of, for example, 1.1. So MHB manhole 1.1, meaning that is the first manhole in network 1. And then we can actually apply it, and you can see that it's updated the labeling, but not everything is correct. So what we need to do is that should be, say, KI 1.1. So I put in my quick properties, and I'm just going to edit the labeling of the structure. So KI for curb inlet, MH for manhole 1. So KI 1.1, meaning on network 1, that's the first curb inlet. Here it's supposed to be MH 1.1. So I'm just going to take out the 2. So this is the easiest way currently to actually label this. Otherwise, your manual copy and paste is going to take you forever. This is still much more better. All right. So here we are. This should be KI 1.2. So that means on network 1, this is the second KI. I hope you following my logic here. Again, you can apply your own labeling convention. I thought I'll just keep it simple and use what normal consultants are actually adopting into their design. So it's as simple as that. That's how you would normally label your pipe network. You'll select the start structure, you'll select the end structure or pipe, and you will label it according to what branch or what segment it is in the network. Okay, so I hope that makes sense. So I am talking through this fairly slowly because I really want you to follow me on here. It is a lot of technical content that we have to get through today. Right, so the second one is creating long sections and editing the vertical profile. Now, I have seen, if I could be quite blunt, nightmares of long sections. Reason being is I've seen a lot of users, even though that they have Civil 3D or any other type of intelligent tool to automate long sections, still use AutoCAD. And that is really a nightmare. Okay, I'm going to show you that if you do have Civil 3D and why you should get iDAS, right? I'm going to show you why this process is so much better. So let's have a look. So now that we have relabeled that branch, I'm going to go to the iDAS tab and I am going to go click on there. As you can see, or you should see now, that there are errors here, which is normal because we do not actually input all of the design data. But what we're going to do is we're going to use the function for designing or drawing the entire network. Okay. So you're going to see now, I can go and select whatever I need on the screen as you're seeing. The main thing is I'm not going to create an overlapping alignment. Reason being is that it will more or less create long sections for no reason. You can do it depending on what your requirements, but the main two buttons that you would need to look at is the style and the band set style at the bottom. Make sure that your references are also correct, so your labels or your surfacing. So I'm going to make sure that my style and my band set style are the same. That is very critical to create it. And of course, with any software, the command line is your friend, right? Your best friend. So I'm going to select the top structure because I know that's the upstream structure on my network. You would know it what's on your network as well. Hit OK, close this up, and this is the profile. Now, I have intentionally done this, right? Reason being is even in Civil 3D, you get this problem, right? Let me know in the chat box if you do get it quite a bit. I did get it quite a bit, right? Where you'll see the structures going off the roof, right? It's going through the, I don't know, probably to the heavens or something. We can actually adjust the inverts. So this is a really cool functionality built into Devotech iDAS where we can adjust the elevation or depth of it and we can make it reference to above or below the surface. If I hit OK, check this out. Brilliant. Everything is sorted out. I know a lot of users normally on technical support will phone me and say, hey, I have to do this manually for the structures, it's not linking, I tried this. This saves you a lot of time and it applies it to all of the long sections. So let's maybe zoom out a bit. Let's have a look here. Check it out. Everything is done correctly here. Okay, you've got these legends for NGL, EGL being your energy grade line, HGL, hydraulic grade line, NGL, natural ground level, a lot of abbreviations, right? And as you can see, there's also question marks. That's because we have not run an analysis. Certain things I have enhanced here. So if you see on the right hand side of the long section, a line that's shooting out a bit, I just wanted to emphasize that you do have those different legends for NGL, EGL and stuff. If you want to adjust your pipe network, this is Civil 3D 101. You can use the grips as you're seeing here. If I go and select the square grip, it picks up the entire pipe, but you can see that it is still linked to the structure updated at the end. But that's not always ideal, especially if you have a really long network section. What we can do is, if there's something wrong with the network, like for example, if you just want to reset everything to a certain standard, we can use the regrade button as you're seeing here. And I can go and set my minimum and maximum covers. I can make my match to a crown or invert. Most videos use invert, so I'm just going to use crown, so just to be different. And here we are. You can see once we do that, first of all, the structures are aligned perfectly to the actual NGL, or the natural ground level. And there's those question marks I've been talking about. Okay, so let's just maybe position this a little bit. Again, I said I've enhanced that just so that you would notice it. You wouldn't get it, but if you do get it, you can actually regrade your network, resize your piping, and it will be 100%. I just want to show you what you might encounter and how to solve it, rather than just giving you a perfect demonstration, right? So let's say I wanted to grade these pipes, meaning that I wanted to maybe match them according to a certain criteria. So I wanted to start maybe at this structure, and if I move towards the right, I wanted to end there, right? Again, command line is your best friend in Civil 3D. If you've been using Civil 3D, you should know that now, even AutoCAD, right? Please check the parameters that you're using. I'm going to use crown. Again, I don't want to use invert because, like I said, it's the most common one used. Let's be a bit different here. And once I hit enter, it will automatically calculate the pipe slope to that position when you hit enter based on the invert. And you will see that it drops it. And you will notice that the crown of each pipe is aligned, which is great. So it's tying into the invert on the right, but you can see that the crown of each pipe is matching. That's why you can see that other invert probably needs to be adjusted, or you can maybe redo it. But if I want to actually input a proper slope figure, so like maybe 1:200, we can do that. So I'm going to go through the same process, but at the command line, I'm going to type in 200, hit enter, and let's see what happens. As you can see, the pipe now is shooting out of the ground. Please don't do your designs like this. Stormwater shouldn't be that way. You need your minimum cover, but I'm just giving you an example where you can actually add in a specific slope, right? So I just undid that. Let's see, what else can we do here? Yes, so let's maybe move on to this side of the network. You can also grade backwards. What I mean by that is, actually, let me just show it to you. So we're going to do this pipe, right? I'm going to go to grade pipes. I'm going to select the structure at the end and then the structure before it. So you see the order, I've swapped the order. Same story with the command line again. And if I just hit enter, can you see it graded it back? If I wanted it to drop from the second structure to the first one, I would have entered negative and like -200, and it would have sloped the other way. Again, I can just go and update or regrade stuff if I want to, but it's not necessary because it is very dynamic in nature. Okay, and of course you got the outfall on the right. That's what that symbol, that hatched blue symbol, means on the right hand side. So again, the functionality is great. It's absolutely great. If you're going to be using AutoCAD to this is going to be a nightmare. I would just have to say snap, copy, paste, offset your entire day, which is not ideal as a civil designer, right? So you can see that there's a lot of streamlined features. You could have also swapped pipes, but I gave you an example of that in the first webinar. You can swap the pipes, you can swap the structures simply by clicking on the log section and entering your diameter from your catalog. Simple, straightforward, but I know normally in consulting, the hardest thing is the actual grading, and you can see how much easier it is right now. Okay, now let's look at another part that's normally done on Google Earth. Okay, so what normally consultants who we used to do in civil engineering is find the site on Google Earth, put a pin, and then use a polyline, increase the thickness, and just draw what you would feel is the contributor area or the catchment. It did work to a certain extent. I'm not going to shoot it down totally, but it wasn't as intelligent. Definitely not. It led to most designs being very conservative. Conservative is fine, especially with water, but if you've been super conservative, it affects the costing, it affects everything. Okay. So I'm going to show you now how you can again do it in one software, which is Civil 3D with the add-on of iDAS. One application, one interface. So let's have a look here. Okay. Right. Let's see. So we stopped here at the long section. Let's just zoom out a bit. By the way, the long sections on the left are the road, so just don't get confused, right? So here is our sections. Okay. You can see that there's tiny arrows on the actual surface, but what I'm going to do is I'm going to run the watershed analysis again. Again, this was covered in part 1, but just a quick recap in case you forgot or you're a bit hazy. I'm just going to run the analysis very quickly. Okay, and you should see it gives you the crests now. Can you see that? Now, how awesome is that? You can actually see the drop or the potential flow of water depending on the actual elevation of the terrain. As you can see here, the water is going to be flowing down that way, it's going to be flowing down there. And these crests can actually help you to size your catchments. So for example, I'm going to do one with you, right? So we're going to be doing it for that curb inlet there at the bottom, where we are going to be running what we call a water drop analysis. So this is very insightful tool. So if I had to click anywhere, let's say maybe there, it will give you the potential flow of water from that point. Can you see that? You can go crazy. What we normally do is we just click a bit wildly, but if you do get you have a really good solid design, you know more or less where to click for critical areas. And as you can see, it's giving me the places where the water is actually flowing away from my road, which I don't really need to worry about. It's showing me the longest flow path. So you can use this to generate your flow paths rather than doing a polyline in Google Earth and getting the measurement of it. Or you can even plot it in here, which I'm going to be doing for this demonstration because a lot of people have that understanding. So as you can see, my road's designed pretty good where the water is going to be gravitating towards the channels and then moving to the inlets at a certain position. So I'm going to draw a polyline for the curb inlet on the left hand side. So let's maybe just zoom in a bit. All right, I'm just leaving it thin for now, but I'll make it much more bolder. So you see, I'm trying to keep in with your Google Earth methodology because the methodology it's right, but you weren't using the actual intelligent tools that you have at your disposal. So I am going to create a perceived catchment, what I would feel is the contributing area to that curb inlet. Okay. Yeah, so let's just draw this very quickly. Again, I'm doing it very rough. You will be much more detailed in your approach, maybe much more accurate. But if you know about surfaces and the data, you can cater for those discrepancies. So you don't have to be 100% accurate here. So I'm just going to cross there, which is very important for generating the next steps. So I've created the catchment. I am just going to make it a bit bolder. Here we are. And this is the contributing area for that curb inlet there. Right, so I've got other curb inlets at different locations where the water would probably gravitate. Okay, and what we're going to do is, just to save time, I've already drawn them. So I'm going to select this and delete it. You understand the methodology. Again, all my webinars are based on understanding rather than what you're seeing on the screen. I want you to understand what I'm doing, right? So I'm going to unfreeze this layer. I've already bolded it for you. And here we are. The magenta lines actually represent the catchment. Here we are. So let's have a quick overview of it. So again, I applied the same methodologies. I'm just going to bring it to the front so you can see it much more bolder. Perfecto. And here we are. This is the contributory areas. So you can see for that catchment, that curb inlet's going to be critical. For this one, we have an actual low point. If I zoom in, so you can see even my super elevation is draining to that low point. That's where you see that circle with the X, that marker. It's actually telling you, hey, that's a common low point that the waters can actually be going to. Very important if you're a road designer as well. I'll give you an example for this catchment. Let's check the water part. So again, water drop analysis. Can you see it's linking perfectly to my curb and channel configuration on my road, and it's going to be draining to my catchment at the bottom. Again, I can click more and more of them just to give you an example, but you can see this helps you a ton when you're trying to size it. There's another low point, and my curb inlet is actually positioned correctly, and it means my road design is on point. So again, roads and stormwater, if you're both on this, well, I can see a lot of you are, please work together to get a good optimized design. It's very important, right? So again, these are the water drop analysis. I'm going to switch them off because I don't need them, but it gives you a pretty educated, insightful guess. I don't like using the word guess, but you understand what I'm saying. It gives you more insight into your design methodology. And as you can see now, we have all our catchments done for each of our curb inlets. So each one of them has a drainage point. You must have that, else it's pointless if you don't have a flow point in your catchments. That's not practically correct. Okay. Like I said, this is a very technical webinar, so I hope you are following me. And yeah, like I said, if there are questions, you can leave them in the text box. I can see there are a few. Or if there's any comments, please feel free. I'll address them at the end. The next thing is defining the properties. Now, this is where we would normally use Excel sheets. I remember having my own Excel sheets, put all the formulas in, your rainfall intensity, like all of those things, right? Calculated, formulated, and you just copied them to each project location and edited the data, your C values, your roughness, like everything. You normally had a formula for this type of thing, especially for rational method. But this is a very technical part of it. So I am not going to go and explain each and every engineering theoretical application. I think that you would need to do a bit of homework on or browse up on your studies. If not, and you do get confused, you can reach out to me at the end of the webinar. Our details will be there. But just to tell you that you're not going to be lost, I want to show you the awesome help file that is with the Devotech iDAS Civil 3D integration. So if you are a novice or a beginner in design, or you want to more or less confirm your design workflow methodology, which is great for anyone, irrespective of your design experience, this help file is amazing. It has all the topics, especially like the methodology that I'm showing you. It's also detailed in here, so you can have a look at it, how it's done, the understanding behind it. And not only that, the calculations that are built into the analysis part are also displayed here. So you will see just now, for example, Kirpish and Kirby. I don't know if you recall them, or if you are in Stormwater, you should know here we go. The Central Drainage Manual has all of this in there. All right, so your time of concentration, your IDF curves, which is intensity, duration, frequency. There's your C values or your roughness coefficients. How you calculate the slope, which is 0.85. This one is a limb multiplier. So you get two types, which is rescending and ascending, right? This explains it quite good, but in practice, normally, I think ascending is one, rescending is two. But again, you can go and read this and understand it much more better. You can see all of the graphs are also in here from our manuals. And again, this can be used throughout the world. If you're applying it, a lot of the design standards in Civil 3D are mostly global, but it's also, with this, you have the application for South Africa or Africa, because a lot of our designs are used throughout Africa. So yeah, I just wanted to show you all of this. So if you think that I'm not explaining it, or you feel a bit lost, or you think it's a bit gibberish, please go and download the trial or have a look at the online website, which goes much more in depth to the actual theoretical part of it. Okay. All right, so just know that you do have help, and of course you do help us here at Baker Benz and iDAS to actually help you out. So let's jump into it. So now we are doing the technical data for the rational method. So here is our catchments. All right, I'm going to select them all. So normal, select, similar, like in AutoCAD, and I am going to create parcels from them. So again, you can select different types of parcel styles, which you can link to iDAS. Not going to get really into that, but I'm going to select a catchment style. Just give it a few seconds. You'll see it's hatched. Here we go. And if I zoom in, it gives the area per name, so number of the area, so area 1 and the hectares, sorry, area already attached. But what I'm going to do is I'm going to just edit this style quickly and switch off that hatch. So let's go and just edit there very quickly, switch off the hatch or the fill and apply OK, or I could just hit OK. I think it's habit. This is going to make it much more easier for us to use. Okay, so the intelligence is still attached. And now what we're going to do is we're going to go to the iDAS tab and we're going to make use of the Stormwater Manager. Okay, so let's just go here. Oh, before we go there, I can actually show you that all of these parcels are now on your prospector and the sites. So all of the catchments are listed there. Just an FYI, so if you want to find it, you know where to go. Right, let's now go to iDAS. You can see that all of the values are 0 because there's nothing created yet, which is the point of this. I'm going to do it from scratch. It is built on the ePerswim engine. So you can also do an ePerswim analysis. You can show the columns or you can hide them. Also, just want to toggle you through the different types of tabs that you can have to check, which we will be going through further on in the analysis part of things. But for now, the important thing is the catchment. So I can hide or show the ePerswim columns, but since we deal with normally rational method 1 here, we are going to be doing it via rational method because a lot of people use it, understand it, and it works. So I'm just going to make that a bit bigger, and we are going to go and set the inlet structure or the draining point of each catchment. So let's go. As you can see, if I click on each catchment, it actually zooms to it on the Civil 3D background, which is more or less ideal if you're using 2 screens. So if you do have 2 screens, this is awesome. Actually, I think I'm going to go and switch off those polylines that we initially created for the catchments because I can't really see because of the colors I used. So let me just go to the layers quickly. Just give me a second. We're going to go there. We're going to just switch off the actual catchment polylines. Here we go. Much more cleaner, right? Cleaner drawings are way better. I think any designer will tell you that. So let's get back in here. Okay. And what we're going to do is we're going to go back to that catchment properties. You can see we still got errors there because we didn't put in a Manning's coefficient. So we're going to get to that just now. Actually, let's just put it in now. So I can fill it for all, I can fill it individually. I'm going to do it for all, right? So each one can have its own custom roughness coefficient, but I'm going to put 0.013, your normally Manning's, and now you see it's all good. So we know that's done. Again, I've also put in, you can see like in the 4th line there, or the 3rd line from the top, it's in bold. I'm going to explain why. That's just to show that you can override the values. So now you can see it highlighted the catchment, pretty easy to see. It's in red. I selected the catchment that it, or the curb inlet that it's going to drain into, and we're going to need to do this for each catchment, which is pretty damn easy. Okay, so we're going to go and select that. Let's do it for the next one. So we've got a nice big catchment there. It's going to be draining to that curb inlet there, so select that. On to the next one. We've got that, which is draining to the bottom there, so we're going to click on that. So as you can see, you are already defining the inlets for each one. It also has an option to automatically define it. So if you did your design very good and there's just one inlet, or your catchments are drawn pretty damn good, it'll automatically pick up that there's only one structure in there, and it'll pick it up for you automatically. However, you can do it like this, which I am doing, which is pretty easy. Is just clicking on where you need it to be. We're going to click the catchments. Here we are. So we've got that all selected. All the curb inlets are selected. And as you can see, the average slope is not. This is where the flow parts come into place. So that polylines that you would draw in to predict or presume the longest flow path. So you can either draw it, which we're going to be doing here because a lot of people understand it, or if you had your water drop analysis on, you could have selected the possible longest flow path from there. So let's do this one. Again, this can be debatable. You can tell me yes, you can tell me maybe no. Again, it depends on your understanding of the site that you're doing, right? So I am anticipating maybe that's going to be the longest flow path, right? That could be correct, could be not. You can go edit it after that, but I'm just giving you the methodology behind it. So again, you can see that it didn't update because it was bold. I'm going to clear the overrides. So what this means is if you're going to be drawing and you have a certain slope that you want, you can actually override your actual line, which is pretty good. And it's bold to show you that it is overridden. Okay, so let's draw the next flow path. So I think the water is probably going to come down there, flow along my channel, and drop into the actual curb inlet. Right, perfecto. We just got a few more to do. So again, main thing here is just understand the methodology, understand what you're doing, what's your purpose of it, and you will be great. You'll be fine at it. Okay, so a lot of this you will be normally doing again with Google Earth, with plain AutoCAD, and just working in 2D. So certain parts of your process it is correct, but the application with the technology is incorrect. So again, we're just creating these flow parts. I just got like 4 more left, so just bear with me. As you can see, it's a bit bolder, like in cyan, because of the layer that it's currently selected into. Yours might not necessarily be that color, so again, I'm sure your color matching is way better than mine. I'm just using the out-of-the-box configs or the ones that I created in part 1 of this webinar. All right, so let's just do a few more. Okay, so this one is going to be a bit of a longer one. So you can see the flow paths are really game changer in terms of your longest trace or your longest flow path. It gives you a very educated, insightful design process to follow. Okay, and again, I can't stress this enough. Your road needs to be designed to facilitate your stormwater network. Very, very important. It's no use having a great, fantastic stormwater network. Actually, you can't have one that's not dependent on the road. The road is dying bad, the stormwater network is generally going to be bad. If not, if everything's good, both will be good. Okay. So again, I think this should be the last catchment. Let's just carry on here. It's going to come down there and it's going to go with my super elevation to that low point. Okay, actually one more. So let's go back here. And last but not least, we're going to go draw a flow path. Again, if you had already existing polylines that you drew, you can also use the option to say select polyline as flow path. So you don't have to draw them. So if you've got a draft person or you got someone that's worked on the flow paths, already drawn it in for you, please don't go and recreate it. Rather just go and use the option to select polyline and you would be good to go. Okay, so that should be the last one. Okay, so I think we've got all of the flow paths done and dusted. We've got all of the catchments done. Now we have also inputted the data because when we did the flow paths, everything populated as you saw, right? Okay, so now let's just finish this off very quickly. So click here. It's going to pick up the location. So that X is the draining point, of course. I'm sure you probably put that together by now. You can also add in the type of formulas that we're using, just before I forget. So the rational method, we're going to be using Kirpish. The formula, you could use Kirby, but I'm using Kirpish. And then, of course, you can add in your return period and of course the IDF graphs, which are based for South Africa. So great, that is set. Runoff coefficient. So this is normally your C factor. You can create a combined C factor. I'm going to let you check that out on the iDAS website. But if I know the exact factor or you're still using Excel sheet for some reason, you can input those manually in here. So whichever is comfortable for you, you can do that. I am going to go apply this 0.85 to all of them. Right. So if you're calculating your rural, your sparse grass, all of those criterion that you normally do on campus or on your SAML drainage manual, you can input those data in there very easily. And you should see now things are already getting populated very much more easier. Okay, so all the data is in. We have green ticks all over. In terms of the actual design data, we got it set to rational and steady flow, very important. And then you can actually go and set a hydrodynamic diameter. I'm going to make mine maybe 1.2 meters. You can have it normally 1.5. That means that it's going to be resized in the pipes depending on the analysis that it picks up. Okay, and of course the flow depth I'm using is 80%. All right, so as you saw, there's no report there. That's because we did not run the analysis, which is the next step. Okay, right. I hope you're still with me. And now all of those things are done. The easy part is actually run the analysis. Okay. But again, if your methodology is off and you don't understand what you're doing, your analysis are going to come up with an error. And I don't want that happening to you. Okay, so let's check it out. Okay, so you can see there's no report currently. And what we're going to do is we're going to run a hydrodynamic optimization. You can see it was a success, which is great. That's a full report of your network that you can actually copy below, export, but doesn't mean that you don't have to check your network. It means that the analysis was successful, but you need to go and check if the pipe diameter is passed. So you can see those ones are flagged. I am going to apply a minimum diameter based on the steady flow analysis that we calculated, and it will automatically upsize those if they do not meet the minimum requirements. Pretty great, eh? You don't have to export to SSA or like do it from different workflows. If you are a civil designer user, you can bring in your data or export your data too as well. So it's a very holistic approach for water design or pipe networks. And as you can see, those are pretty good. My flow depths are pretty great. 80% is a really good ratio to have for your networks. You don't want flooding to happen. But that's just how easy it is to actually run an analysis. But it all depends on your methodology. Last but not least, so you might have thought that, hey, that analysis went perfect. What if you do get a warning or something like that? Don't worry, I've got you covered. So I've done a second scenario for the bands. So let's have a look. Okay, so I'm giving you both cases because I'm also a designer, so I understand what you're doing. Right, so let's have a look here. If I zoom into the actual long sections, can you see that the values haven't updated? It's still question marks, right? So let's go and run the analysis again. But this time, pay attention to what's going to happen on the top right there. Can you see there's a warning? Right, if you do get those, don't panic. It's because you did not apply the minimum upsizing. So if I hit OK, that should say success now. Let's see. Here we go. All right. So even if you want to see the troubleshooting, you can go to the report at the bottom. Now, make sure that you check update parts lists. So once you close it, you should see those question marks update. And all your bands are now correctly with the correct data. And I don't know if you noticed there, but on the big one, that line that I had shooting out in the initial segment has also corrected itself. So the energy grade line as well as the hydraulic grade lines are great now. If it's still shooting out after all of the analysis and pipe sizing, you need to go and check something out. Either your structures are probably flooded. It could also be maybe the pipe for some reason needs to be maybe upsized, or just go and apply your technical knowledge. You might pick it up. Easiest way is to go to the iDAS report and see from there what error has been picked up. Okay, that is enough information overload for Friday. Again, I said this will be the most technical segment of the series, but let's wrap it up and let's see what we actually can take away from today. Alrighty, so today's takeaways. First of all, what we did was we ensured that the labeling was done in a logical manner. So even for construction or for drawing production, it's going to make a much more sense, right? What's going on. So we labeled the branch, it was all good. We used the naming convention where we said 1.1, 1.2, 1.3, where the first one stays constant, meaning that it's branch 1, and then 1.2, 1.3 means pipe 1, pipe 2, pipe 3 in branch 1. Bit confusing or tongue twister, but I'm sure you understand what I'm saying. And then after, we created the long section pretty easy using the draw entire network profile in iDAS functionality. We generated all of them. We did some editing, vertical profiles. We matched it to the crown. We matched it. We checked the inverts between the structures. We also graded backwards. We graded forwards. We entered a specified slope. We used the grips. So those are the easiest ways you can actually do it, and it worked perfectly. Then we did the part that normally challenges a lot of engineers, which is systematically defining the catchment, right? So we use the watershed analysis, we use the water drop, which is brilliant to help us understand what's going to be contributing so that we don't create an overly conservative design and we do not create a over contributing catchment. Okay. Sometimes it could be in your favor, sometimes not, but this is very streamlined and much more to the point and precise. Thereafter, we inputted the data for the rational method. Again, all of it was explained in the help file. So if you're still confused on what's kerpish, what's rescending and ascending limb, where we get the values from, the combined C values, roughness coefficients, what's a Manning's, all of those things. If you're not experienced in stormwater design, have a look at that. Alternatively, just go online and check the Sanral drainage manual. It's pretty good. You will understand what they're saying. Then after all the hard part was done, we simply clicked the button and we ran an analysis. We saw it was a success, and then we said, hey, we still need to check our pipes. We checked the pipes and we saw that we needed to upsize them because they were flooded. So we applied a minimum pipe sizing to them using steady flow hydrodynamic optimization analysis. Once that is done, everything was ticked great. We updated the Mannings to say 0.013 to remove the actual error that was initially there. And then we hit analyze and it was fully successful. Also then the grade lines for the energy and hydraulics were updated in the long section. We then updated the parts and we ticked on the update list when closing the wizard. We hit OK. And then after that, the profile, the long sections was updated successfully with those question marks disappearing. That's where we updated the plan. Okay, so that was a lot. It was a lot, but I hope that it made a lot of sense as well into the application methodology that you would use. And I hope that it was very beneficial. So before I wrap up, these are our handles as Baker Bains. Please reach out to us, follow us on LinkedIn. We're on LinkedIn, Facebook, Twitter, Instagram, YouTube, whatever's your flavor, we are there. So reach out to us, comment, like, subscribe, especially our YouTube channel. For those that were inquiring about the recording, it will be uploaded to the YouTube channel. I always say this in the webinars, if you cannot attend for some reason, still do register. Reason being is that as soon as the webinar is uploaded, you will get a link to go and access that at a later time where you can watch the recording and digest it for yourself. And last but not least, if you would like to connect as a fellow designer, we can connect, right? So if you have any differences of opinion, or you might have any things you want to discuss with me, you can reach out to me directly. Again, I'm Shem Yunus, the BOOM technical specialist here at Baker Bains. anything civil infrastructure design. So I'm a civil design engineer. If you're talking more or less product focused, those are my everyday go-to products. Civil 3D, InfraWorks, Recap, laser scanning, PERM 360, and of course iDAS. So you can reach out to me if you have any questions or any suggestions, or you need any help with anything. And of course, my secondary focus is more on the structural or build part of things. So your advanced steel, Revit structures, robot structures, and of course, Navisworks works for coordination. So if you are product specific, you know what you're looking at. All of my webinars, the upcoming ones, as well as the recordings, I always post them on LinkedIn. I think that's the most active platform I am on for social media. So please, if you want to follow me or add me or connect, please search and stay in tune to our YouTube channel, our Baker Bains LinkedIn. If you want to drop me an email, if you have any great feedback, or if you have any constructive criticism, if I could say that, feel free to send them. It's always great to see or hear the insights of you that are in industry, in consulting, and facing challenges. And another great thing with that is, if you have something that you're grappling with every now and then that you're struggling with, you want to know if there's a better way to do it, or you hit a brick wall and you can't get through it, drop me an email. We could probably have a look at it, have a chat. And if it's something that's faced by a lot of design engineers or consultants or drafts persons, we could actually do a webinar in the future tackling it and showing and helping a lot of people. A great thing with this webinar series is I saw a lot of professionals tagging fellow professionals, which is amazing. That I can see that on the list here, which is fantastic. So if you know someone that can learn, or you can tag them, again, it's free learning. Please feel free to tag them so that a lot of people can actually learn and grow together. And last but not least is our Baker Bains YouTube channel. If you just type in Baker Bains on YouTube, go hit subscribe and like whenever a video is uploaded. It doesn't have to be civil infrastructure. We do a lot of different segments, like you saw in the initial start of this webinar. We've got architecture, we've got mechanical, we've got process plant, we've got 3D laser scanning, we've got mining, we've got civil infrastructure. We've got a lot that we do webinars on. So if you're keen on keeping up with all the different segments and what's going on, I would suggest subscribe. Alternatively, subscribe anyway, and whenever something that's in your profession in civil infrastructure mining pops up, that way you can be notified and you can learn. Okay, so with that said, I'm just going to open up for Q&As. So if you do have any questions, any comments on this webinar, anything that you want to bring to my attention, please use the text box now. I'm going to give you a few seconds. I'm interested to hear what you thought. Did you find it beneficial? Is there any questions that you have? Anything that's on your mind right now, please drop me a chat and we can have the look at the questions now. Okay, let's have a look here. All right, I did see, like I did say, for the part one recording, it is on the YouTube channel. YouTube, this part two will also be uploaded today. And then when is part three? Part three will be probably end of next month. So just keep an eye, lookout on that, so you can keep up with this series. That will be focusing on of course, the plan production and quantification, which a lot of draft persons are really great at. But if you need help with that, you can actually have a look at the part three that's coming soon. Once the date, it should be on a Friday at 11. We try and keep the same time. So as soon as the date is available, we will make a post on LinkedIn. You can register, tag people to attend as well, and we can wrap up the series on a strong note. Okay, thanks for that question. Okay, so there's a question regarding EPUSWIM. What is EPUSWIM? Okay, EPUSWIM is a freeware that you can use, that's normally used for analysis purposes. So if you just type in Google EPUSWIM, you can the manual or the explanations are all on there, but it's an analysis that a lot of software that actually build their foundations on, and that's the actual engine that's running the analysis part of things. It's very, very powerful, and it's fairly accurate. So you can have a look at them. If you remember what HEC-RAS was, it's more or less in the same type of thing, but EPSWM is much better. So have a look at it. If you do get stuck or you have any questions, I'll put my slide on again, so you can always drop me an email. But that's more or less, it's just an analysis engine, and it's free. So if you want to go and download it and have a look at it, by all means, go and have a look. Okay, I think this person didn't attend part one. So question is, where do you access the pipes catalogs if it's for South Africa? So when you install the iDAS template, there's a template called with part lists. It's a bit larger in file size. I think it's a few megs, which is not bad at all. But when you're normally generating your pipe catalog, even in standard Civil 3D, you need to go and set your part list. And this is what you would have to do once you install this template. You ensure that your piping folder is routed correctly, which is normal practice in Civil 3D. And once that's done and you start generating your pipe network, you will see in that drop-down list all of the structures and all of the pipes. So for the example, or for this webinar series, we've used Rockler pipes, which is commonly used. We've used manholes. I think it was, I'm not sure if it was JRA or Swane. And then we use also the curb inlets that are Swane specific. There's a lot more there. There's GRA there. There's quite a lot of municipal specs, if I could call that, in there. So have a look at it. Alternatively, head off to our YouTube channel and you will have a look at that. But thank you. That's a good thing to actually recap. Okay, there's another one here. Which is your next webinar? Okay, so if you've been following us on LinkedIn and on our social media platforms, you should see that we had a various different campaigns that I have also been involved in. The two primary ones being this water for stormwater design series, as well as a scan to boom workflow series. So there might be one more scan to boom workflow series that I'm probably looking at. If not, the last one was, I think it was last week, where we finished on combining CAD and photorealistic visualization. Again, you can go and catch that on the channel. So after that, I think I'm open for topics. So if you do have any suggestions, feel free to drop me an email. We can have a look at that. But I think we'll take it as it comes and see what the users want to see. What's gonna what's gonna happen once the stormwater design series has been complete? It has been complete. I can't do much. And if you want more information, again, you can always reach out to us. Alternatively, you can head on to the iDAS website or YouTube channel as well. The details or the videos are much longer than what you've seen here today because they explain and go very slowly through the concept. So I think it's a very good way to go and learn more and understand on the actual process. I would say, depending on capacity as well as what's going on this side and what the users want to see on the design, I would like to do maybe the next series based on maybe sewer. It's very similar to this though, so that's why I'm still contemplating it. Let me know what you guys think. Sewer would be fine, or maybe we could do maybe bulk reticulation or water design. So I would probably do something in pipe networks again because we're getting a lot of questions on that. But I haven't, or we as a company, we haven't decided our final approach yet. But that's why you have to follow us on our social media to actually keep in touch. Okay. Okay, there's one more question that came in regarding the watershed. Are these styles pre-built into Civil 3D or are they specific to the iDAS template? Okay, very good question. First of all, the watershed functionality is in standard Civil 3D. You would see it there. But when it comes to the styles, they're completely different. Remember, styles and I would say the customization part, there's more styles available and more functionalities available with the iDAS template compared to normal Civil 3D, hands down. So that's why I would strongly recommend using that template. You can download it off the iDAS website as well. Also, when you install it, there's a file or folder location with all the templates that you could use. It's very, very powerful and it works amazing. I, in fact, use that on my Civil 3D designs and applications. Okay, I think that's it. I have went through all of the questions. Thank you so much for joining me. It's great that you guys followed. Again, keep tagging people, keep showing up, learning together. I also learn by doing these webinars to teach or to showcase to you. So we are both benefiting from each other. So on that note, I would like to say thanks to everyone. I hope you have a great Friday, a great weekend ahead. And I will catch up with you soon, either by email, LinkedIn, or the next webinar. So have a great day and see you all so much soon.